Hi class, in this section of work we're going to be looking at pictorial drawings, and this is chapter 3 on page 42 in your textbook. We're going to focusing specifically on isometric drawings and how to do them on a drawing board. I've explained a little bit about isometric drawings, perspective views, orthographic projection and the differences between them in some of my previous videos and also in the section on freehand sketching. But in this video we're going to physically construct them with our drawing equipment to do them a lot more accurately. So why do we need to do isometric drawings when we've already got orthographic views? Well, the reason for that is sometimes it's difficult to see what you're drawing and what your object looks like from your orthographic views, and it is helpful to draw like in this picture here. We've got a three-dimensional view of the object, or even almost as though it's been twisted sideways. As you may recall from the last video, this is my GoPro camera case. Orthographic views would be like this, from the front and the side and the top. But if we want an isometric, then we are turning it at an angle. All right, so we're tilting it down and we're looking at it at an angle. So that's a three-dimensional view of your object. So how do we construct this with our drawing boards? Okay, let me just demonstrate some of these examples, exercises in the textbook. So the most important thing to remember when it comes to isometric drawings is that we have to draw our isometric axes when we start. All right, so let's start off by drawing a relatively simple block that's in an L shape, as shown on page 43 in your textbook. So the first thing that you would do in any isometric drawing is decide where you want to place it. I'm going to draw it up here. I'm not really going to use dimensions at this point. I'm just going to show you how it works. You will draw your isometric axes. So these are construction lines. There's a horizontal line. I'll draw a vertical line. And then also I will draw my isometric axes, which are at 30 degrees on either side of that vertical axis. Right, so that is my isometric grid system essentially. So that would be 30 degrees and that is 30 degrees. So my entire isometric drawing is based on this principle, that we have a 30-degree angle between them. All right, let's say our orthographic views look something like this. I'm just going to quickly freehand sketch them. So that would be the front view of our block, and the top view would look something like this. So that would be the top. So you can see the front view has got this L shape. The top view, you can see the two different heights of the material. The rest of the block is just straight sides. So I'm just going to take some random dimensions here, just mark them off. So what we do is we decide where our front view is going to be situated. So in this case, I'm going to use these two axes to represent my front view. I'm going to use this one to represent the side view, and then the top view will be looking down like that. So we're essentially taking those two views and reproducing them on each of these axis systems, but we are adjusting, we're tilting the axes. So if we take that front view and we measure up from here to here, let's make that, let's call it 20 millimeters. Let's say that that is also 20 and that's 20. So, and that would be 40. So yeah, that would be 40 as well. So, and it'll be 60 total. And let's call that 40. So let's just make up some random dimensions. All right, so I'm going to reproduce this shape on these axes. So I take that bottom length there, 60 millimeters, and I measure that off. 60 millimeters. Now from that point, we have a vertical line going upwards in that direction, and that I would use. From that point I would draw a vertical line upwards, because our vertical lines stay vertical. Alright, from the front I measure up 20 millimeters, and that's a vertical dimension, so it's also on the vertical axis. So let's measure up 20 to there. Now I've got to draw this line, which is a 40 millimeter line, but now that is along our isometric axis, which is this one, so I will then construct it in this direction and measure my 40 millimeters over there. And now I have a vertical line again there, which is 20 millimeters long, so I can construct that going upwards, and I know that this height here is 40, which I can measure. And then that line is on the isometric axis coming back again, so I can construct that down, and that should give me a height of this portion of 20 millimeters. Where is my 1:1 scale? So pretty accurate, 20 millimeters. All right, if I just take all my construction lines down a little, I can see the block. So you can see we've taken that L shape and we've essentially lifted it up, we've twisted it into a parallelogram. Now we've got points that we've created on our isometric axis. We can then transfer those in the opposite direction. So let's look at the front, or the side view, which is looking from this side. We would have that bottom section going across, we'd have that flat portion there, and then that vertical section. Okay, so we can essentially, along with this axis, transfer these points across along the isometric axis. Okay. All of these points can be transferred at our 30-degree isometric angle. We know that we have a 40 millimeter length of this line, which is the same as that front length, measured along in that direction. So we measure that off, and now we have a vertical line we can transfer upwards. So there's the front face. We can also just take this up. You can also take that point and take it backwards to where it intersects pretty nicely with that point. It goes up from there, and then this point can be taken backwards. So essentially, because of the geometry, we end up with that line being exactly in the right place. It's not always going to happen, but in this case, that is how it worked out. So here we have our isometric drawing of that L-shaped block that I've represented over here. Alright, so our top, this is the side, and this would be front. Those views. And I can draw over the lines darker if I would like to. I'm not going to bother too much at this point. Okay, so you can see the basic principles. We start with our symmetric axes, which are 90 degrees, and then our 30-degree axes in each direction. And then we reproduce the geometry of the drawing on those axes, measuring and taking them across. So everything that is either parallel or perpendicular to one of the sides of the block would be along one of the axes. What happens if this block is not rectangular in its geometry? That I'm going to show you in the next exercise. So in the next exercise, I'm going to draw our symmetric axes down the bottom. Let's just do a vertical line here. And then some asymmetric axes going in each direction. Alright, so now the next exercise, we have a block. The orthographic view looks okay, let's draw the front view. Looks something like that, and the top view will look something like this. So it's in line with that point. So we can see that the sides are tapering towards the top. Let's give it some random dimensions. Let's call this 80. Let's call the height 60. And let's say it steps in 10 millimeters. Right, this one can be, let's say 40 by 80, 60. All right, so we've constructed our geometric, our isometric axes, which are 30 degrees. Now we start by identifying which views we want on which axes. So let's say that this is front, and we want our front in this direction. So therefore the front is going to be in this position. All right, so we have that dimension 80. So that's going to be measured along that axis because that is on the axis. So that's quite easy to do. We measure that 80. We can draw a vertical line there. And we can also take our isometric geometry in this direction. We've also got a 40, this depth here, so we can draw that, measure it out, draw that, and just produce this geometry to complete the base. Oh, I've got a step in my ruler there. It was a bit nasty. Right, so I can also take that point upwards, and the height is 60, measured perpendicular to the axis. So I can actually measure it on one of these axes, 60 millimeters upwards, and once again using our ruler we can just transfer That's a bit short. And transfer that to all the axes. So this is what we would call a bounding box. That's a box that surrounds the object, but it doesn't necessarily produce the final shape of the object. It's just a box that will inscribe the raw material. Well, that's pretty accurate. We managed to construct our bounding box quite accurately, so it lines up in all the corners. So there's our bounding box. We'll get rid of some of the construction lines, neaten it up. Right, now we can see that we have a top plane which is offset 10 millimeters all around. If we measure along the top on the axis, we measure 10 millimeters. We can transfer that across. It's also 10 millimeters in this direction. All right, I don't know if I put that on. So this would also be 10. All right, so here we're going with 60, with 30 in that direction. You see, our measurements have to be along an axis perpendicular or parallel to the isometric axis. We can't measure this line and produce it here because that is at an angle. In fact, that whole surface is an angle, so we can only rely on the dimensions that are perpendicular or parallel to our axes. All right, so now we've constructed the geometry of the top. I'm just going to draw that a bit darker. Right, so now we've got these corners that join each other. That one and that one, that one and that one, and even that one joins this one. But that would be behind. So once we've created those points, we would have to just connect them without using our specific angles and just draw them in as you see them here. Okay, this ends up being a vertical line, but these two are not. So I will just darken the outlines. Alright, so there we have our asymmetric block with tapering sides. So you can see those sides are not parallel to the asymmetric axes. So that means that you can't measure the angle or the dimension and transfer it, because it won't work out. So you have to transfer only dimensions and angles, or just dimensions in fact, not even angles, that are parallel or perpendicular to the orthographic axes, and then plot them on your isometric axis. Alright, then the last thing I wanted to show you is how to draw circles, isometric circles on page 44. Alright, so to that I'm going to create it on this side. We have a 52 millimeter diameter circle. So let me just measure off 26 from here 26. Alright, so here is our circle. And this is the circle we would see in an orthographic view, or in other words, a view that is drawn with the front and the side and a top view. So I'm not worrying too much about center lines at this point, but I am trying to find, doing construction lines to represent the centers. That was a little bit off. I need to go and look closer. There we go. Vertical lines, and let's draw a box around it. Helps us to visualize the transformation into an isometric shape. All right, so that is a diameter 52 millimeter circle. So we want to draw an isometric version of that. So as usual, we would produce isometric axes, and I will draw the circle twice, producing it on two different axes. Right, so here is our 30-degree line, and here's the other one. All right, so here we have a diameter 52. So that means that this dimension is actually 52 millimeters. And the same is true in the vertical direction. So we can, and that is along an axis, an orthographic axis. So we can transfer that 52 and the 26, which is the center, onto these axes. I'm going to draw it in both directions just to show you that it works. 26, and there's the 0 point. In fact, I'm going to measure the vertical as well. 52 and 26. 26 is there. All right. Let's draw some vertical lines, some centers, another center, and another vertical line. So here's the center, and that's the outside of the box. In this direction, it goes like that. In fact, just need to close that. Yeah, so now I've got two isometric squares. I've got a square there and a square here, and that construction square is 52 millimeters by 52 by 52 high. So what we have to do is construct our isometric circle. So as you can probably see, when you take a circle, let's take this masking tape, for example. It's a circle, but if I want to draw it isometric, you're essentially twisting it so it'll look like an ellipse. And an ellipse is essentially a circle that's been squashed like that. Okay, but in real life, what's actually happening is you're just twisting it and turning it at an angle. So you'll draw what you see from that view, which is elliptical in shape. But the ellipse would be constrained by this box. All right, so what we do is we have to construct the centers. So we're going to do a similar process to what I showed you before, where we construct an ellipse in geometric construction using a large circle and a small radius circle. But in this case, we're just going to do a simpler version of what I showed you once before. So once we've created, let's draw this side one first. We have to do some construction lines. So I'm going to draw a line there. Sure, that one was a little bit wonky. And there's also a line going to that side. And from the opposite side, we do the same. Opposite corner, should I say. So what we've done now is we've constructed the center point. So there's a center point there and there, and that would be the radius of this circle and that circle. And also what we've done is we've got this point, which is the radius of that circle. So once we've constructed those lines, all we do is we place our compass on one of those points, set it to that radius, and then draw it in. We can do the same on this side. Construct a radius. Okay, there you can see the two large radii of my ellipse, and now I can set my compass to the smaller radii. It's a little bit outside, and then draw that in. Oh, this is a little bit out. Yeah, my construction wasn't great, so it is not lining up exactly now. I think it's because the ruler is wobbling a little. Okay, that's pretty close, not exact. You can see a bit of a gap there and a bit of a gap there. Right, let's try it on this side. So we take the largest angles and we join them to the midpoint of the other side. This one, we join it to the midpoint on the other side. And now we can construct our circles once again. Let's place our compass here. We set it to that radius. And we draw the two radii in. It worked out nicely. We place it on that intersection point, and let's see how we're going to work it out this time. Yeah, that's pretty good. Put it there. Now we check. Okay, now this is a much better one. Alright, so here we can see two circles, both the same size, but the ellipses go in the opposite direction because of the face that they are on. If I do it on the top, then the ellipse would go in this direction, like that. Because the box that I would draw would be like that, and you can see it's squashed the circle in that direction. Okay, so that is how you draw isometric circles using this construction method when you know what the geometry is. Right, so that was all on page 43 and 42, 44, and there's an example on page 45 going through to 48 that you need to go and draw yourself. It's a very nice example with some straight geometry, some angled geometry, and then some circles as well. As you can see, those are isometric circles, and yeah, that's showing you how to do those constructions for those circles. So you need to do that. And then we've got some exercises, question 1, question 2. So you need to draw these as isometric. Remember, if you get stuck, you can always have a look on page 60 and you can see the answers are given to you there. Alright, and then the last thing I wanted to share with you is auxiliary projections. And that's really just to mention that when it comes to orthographic projections, so now we're back to orthographic first third angle projection and front and side and top views. Sometimes we're not able to see the geometry of a part in an orthographic traditional view, which is a front or side or a top or a bottom, because the surfaces of that object are at an angle, so we can't see the true length of our lines. So that's one example where we would want to do an auxiliary view. So just take this angled bracket for example. In neither of these views can you see the true size of this section of the bracket, and that's really important because there's obviously something mounting onto that piece of the bracket at an angle. So it's important we get it right. So it's important that we draw that section in its true size. So to do that, we would have to turn the bracket at an angle that is in line with that surface. So an auxiliary view is literally just an orthographic view that is realigned perpendicular or parallel, or the line of sight, the view is perpendicular to a particular surface of interest. In this case, this surface is interesting to us, so we want to see what that geometry inside there looks like. So we would project perpendicular from there all of these lines and then construct a view so that this surface here is drawn perpendicular to that. So here we're drawing a circle in its true shape. All of these arcs and circles are true arcs and circles, and we can see the true length and true size of this feature. Alright, so just read through this section and do some of the exercises as you see them over here. We're not going to worry too much about developments at this stage, but and lines of interpretation. These are very interesting, especially if you're working with sheet metal work and you want to create ducting, like for air conditioning systems. It's very interesting to do a development like this so that you can join pipes together, for example, and cut out shapes. Developing a flat piece of material from a square shape into a round shape. Fascinating. But that's not important for our syllabus at this stage. So focusing on auxiliary projections. Read through these, practice some of these examples, and we'll see you next time.